Hi students, in this video we are going to discuss about the topic non-commutativity of matrix multiplication. In last video we have seen how to multiply two matrices and when the product of two matrices is defined. Consider two matrices A and B and let AB is defined. Consider two matrices A and B and AB is defined. Then can we say BA is defined? No. AB is defined does not imply AB is defined AB is defined does not imply BA is defined. That is, if AB is defined, we cannot say BA is defined. If AB is defined, which does not mean BA is defined. For example, consider two matrices A equal to matrix 2, 3, 5, 6. It is a 2 by 2 matrix, 2 rows and 2 columns, and another matrix B equal to 1, 2, 3, 0, 1, 6. It is a 2 by 3 matrix, that is 2 rows and 3 columns. Clearly, here AB is defined. Here AB is defined. Since number of columns of A, that is 2, equal to number of rows of matrix B. Number of columns of A, that is 2, equal to number of rows of B. So here AB is defined. What about BA? What about BA? BA is defined if number of columns of B is equal to number of rows of A. BA equal to matrix 1, 2, 3, 0, 1, 6 into matrix 2, 3, 5, 6. Here order of B is 2 rows and 3 columns, 2 by 3. Order of B is 2 by 3 and order of A is 2 by 2. Here clearly number of columns of B, that is 3, not equal to number of rows of A, 2. 3 not equal to 2. Number of columns of B, that is 3, not equal to number of rows of A, that is 2. 3 not equal to 2. So BA is not defined. So clearly we can say if AB is defined, it does not mean BA is defined. It may be defined, but generally if AB is defined, it does not imply BA is defined. If A and B are square matrices of the same order, then AB and BA is defined. For example, if A equal to matrix 1, 2, 3, 6, a 2 by 2 matrix, order is 2 by 2, a square matrix of order 2, and B equal to another 2 by 2 matrix, 2, 5, 0, 9. It is also 2 by 2 matrix. Here AB is defined. AB is defined since AB is defined since number of columns of first matrix A is equal to number of rows of second matrix B. So AB is defined. Here BA is also defined. BA is also defined. BA is also defined since number of number of columns of B. Number of columns of B is equal to number of rows of A. Both are 2. So we can note this point. If AB is defined, BA need not be defined. If AB is defined, BA need not be defined. And if A and B are respectively M by N and K by L matrices, M by N and K by L matrices, that is A order is M by N and B order is K by L. Matrix A is of order M by N and B is of order K by L. Then both AB and BA are defined if and only if N equal to K. That is, N should be equal to K and L should be equal to M. L should be equal to M. If A is of order M by N and B is of order K by L, then if both AB and BA are defined if and only if N equal to K and L equal to M. For example, if A is of order 2 by 3, if A is of order 2 by 3 and B is of order 3 by 2. If A is of order 2 by 3 and B is of order 3 by 2, then AB and BA are defined. Then here AB and BA are defined since these two are equal. 3 equal to 3 and 2 equal to 2. 2 equal to 2. Another example, if A is of order 5 by 4, 5 by 4 and B is of order 4 by 5, then AB and BA are defined. AB and BA are defined. Here 4 equal to 4 and 5 equal to 5. Okay. And here one more note is there. In particular, if A and B are square matrices of the same order, then both AB and BA are defined. If A and B are square matrices of the same order, then both AB and BA are defined. For example, if A is of order 2 by 2, a square matrix 2 by 2 and B is of order 2 by 2. Here both A and B are of order 2 by 2. Both are square matrices and their order is same. So AB and BA are defined. And now consider two matrices A and B. Consider two matrices A and B and both AB and BA are defined. AB and BA are defined. Both AB and BA are defined. Then can we say AB equal to BA? AB equal to BA? Can we say AB equal to BA? No. AB not equal to BA. The product of matrices is not commutative. Matrix multiplication is not commutative. AB not equal to BA. For example, consider these two matrices. A equal to matrix 1 minus 2 3 minus 4 2 5. So order is 2 by 3, that is 2 rows and 3 columns. And another matrix B equal to 2 3 4 5 2 1. It is 3 by 2 matrix. Order of A is 2 by 3 and order of B is 3 by 2. then clearly AB and BA are defined. Find AB. AB equal to matrix 1 minus 2 3 minus 4 2 5 into matrix 2 3 4 5 2 1. Then find their products. Multiply first row of first matrix with the first column of second matrix. Then we will have 1 into 2 2, then minus 2 into 4 minus 8, 3 into 2 6. Similarly, first row with the second column, 1 into 3 3, minus 2 into 5 minus 10, 3 into 1 1. Similarly, the other terms also. Then we will get AB equal to a 2 by 2 matrix 0 minus 4 10 3. It is a 2 by 2 matrix. Now we can find BA. If you are finding BA, matrix 2 3 4 5 2 1 into matrix 1 minus 2 3 minus 4 2 5. That's equal to, we will get the answer minus 10 2 21 minus 16 2 37 minus 2 minus 2 11. It is a 3 by 3 matrix. Clearly we can say AB not equal to BA. AB not equal to BA. Here AB is a 2 by 2 matrix and BA is a 3 by 3 matrix. Clearly they are not equal. If two matrices are equal, their corresponding elements should be same. Here order is not equal. So clearly we can say AB not equal to BA. That is, matrix multiplication is not commutative. Here we should note one more point. Generally matrix multiplication is not commutative. That is, AB not equal to BA for two matrices. But this does not mean AB not equal to BA for every pair of matrices. Isn't it? Generally, matrix multiplication is not commutative. That is, AB not equal to BA. But in particular cases, AB equal to BA. For example, if A equal to 1 0 0 2, a 2 by 2 matrix 1 0 0 2, and B equal to matrix 3 0 0 4. That is, A equal to matrix 1 0 0 2. It is a 2 by 2 matrix, and B equal to matrix 3 0 0 4. It is also a 2 by 2 matrix, a square matrix of order 2. Now we can find AB. AB equal to matrix 1 0 0 2 into matrix 3 0 0 4. That's equal to, multiply first row with the first column, that is 1 into 3 3, 0 into 0 0. So 3 plus 0. Next one is 1 into 0 0, 0 into 4 0, 0 into 3. Next second row with the first column, 0 into 3 0 plus 2 into 0 0. Next second row with the second column, 0 into 0 0 plus 2 into 4 8. That's equal to matrix 3 0 0 8. AB equal to matrix 3 0 0 8. Now we can find BA. BA equal to matrix 3 0 0 4 into 1 0 0 2. Multiply first row with the first column, 3 into 1 3, 0 plus 0, 0 into 0, 0, 3 plus 0. Then first row with the second column, 3 into 0, 0, plus 0 into 2, again 0. Now second row with the first column, 0 into 1, 0, plus 4 into 0, 0. Now second row with the second column, 0 into 0, 0, plus 4 into 2, 8. That's equal to 3 plus 0, 3, 0, 0, 8. AB equal to matrix 3, 0, 0, 8. BA equal to matrix 3, 0, 0, 8. Clearly we can say here AB equal to BA. In this matrices, matrix product of matrices AB equal to BA. That is, in this case, matrix multiplication commutative. But generally, matrix multiplication is not commutative. Just look at these matrices A and B. A equal to 1, 0, 0, 2 and B equal to 3, 0, 0, 4. What type of matrices is this? These matrices are what type of matrices A and B? Can you say? These A and B are diagonal matrices of same order. We have studied diagonal matrices. Diagonal matrix means non-diagonal entries are 0. Here 1, 0, 0, 2 non-diagonal entries are 0. Diagonal entry means this. Here also diagonal entry is this. Non-diagonal entries are 0. So here A and B are diagonal matrices of the same order. So from this example, you can make a note. AB equal to BA. AB equal to BA if A and B are diagonal matrices of the same order. If A and B are diagonal matrices of the same order, then AB equal to BA. But generally, AB not equal to BA. Matrix multiplication is not commutative.